This is my circuit to test the 74LS47. It's a BCD to 7 segment decoder, and we're going to use it to drive this 7 segment display here. It's a common anode 7 segment display. You can't use the common cathode display for this particular display driver. Here's my circuit. I have my voltage regulator, which regulates my voltage to 5 volts. I have my 4 switches. These are going to be my BCD inputs. This is 1s, 2s, 4s and 8s. So I can get any combination between 0 and 15 with these switches. Now, because it's a 7 segment decoder, the maximum range of symbols we have is 0 to 9, and we have a dot as well that I haven't wired in this example. So here's the 74LS47. Just take care in the data sheet. You can see that for my particular configuration I had to wire pins 3, 4 and 5 had to be connected all together and all connected to the plus VCC. This pin is connected to VCC, the last pin, and pin 8 is connected to ground. The remainder of the pins are the input pins from the switches, which are in pull down configuration, and also then I have these colourful wires here, which are the wires that run to the 7 segment display. With the 7 segment display, just be careful. You have to have the middle pin on both sides. There's 5 pins on both sides. The middle pin on both sides, because it's common anode, all of the anodes of these LEDs are connected together, and these then have to be connected directly to VCC. So in this case, it just so happens if I look at the diagram of this particular 7 segment display, this pin, the middle pin on this side and the middle pin on this side are tied together. Okay. The remainder of the pins then, each then are connected to one of the individual segments on the display. In this particular case, this pin here is connected to this segment, this one is connected to this segment, this one is connected to this segment, and this one here is connected to the middle segment. Similarly on this side, we have the first pin is connected to this segment, second pin to this segment, the next pin is connected to this segment, and the last pin is connected to the dot, with the exception of the 2 middle pins as previously stated. So that's the wiring of the 7 segment display. You can see that in the diagram. Just to show you now that this operates as we would expect. Okay, so here's my circuit. I'm just about to power it. Just one other thing just to mention before I go on is make sure that you have a resistor, an appropriate resistor value connected to each of the pins that you want to drive. If we just use a single pin, single resistor, we saw this before, if we use a single resistor to drive and connected that to high for the common anode, well, you would see that depending on the number of segments that are lit on the display intensity would fluctuate. So for example, if you were to light 1, it would only use 2 of the segments, it would be very bright, but if you use all 8 segments, then it would be significantly dimmer. This configuration means that no matter how many segments are lit, they'll all have approximately the same brightness, and we'll see that in operation in a second. That's it. So I'll just power it in. So here I've connected the power, and hopefully you can see that with the data sheet, the way that I've chosen it to work is that I want to display a 0 when all of the inputs are 0. That's the way I want it to behave. I think you have an option like that on the data sheet. And now I can get my numbers. So BCD1, I can press this digit here, and that's gives me a BCD1, which gives me a 1 displayed in a 7 segment display. 2 is by pressing this pin, gives me a 2 displayed. If I join 2 pins together, I'm getting BCD input of 0011, which is 3, and you can see that displayed. 4, 0100 gives me a display of 4. 75 is the first and the second one and the last one, which is 0101, which is BCD value 5. Middle 2 is 6, 0110. 7 is 0111, which is 7. 8 on its own is 8 plus 0 plus 0 plus 0 is 1000, which gives us 8 displayed. And finally, if I press this one and this one, I get 9, and then back to 0. Obviously there are more combinations, and the data sheet allows for a set of symbols to be displayed. So for example, if we go to 10, press 8 plus 2 is 10, you see we get this symbol here displayed. 8 plus 2 plus 1 is 11. We get this displayed. 8 plus 4 is 12, we get that displayed. 13, we get that displayed. And so on. So 14, we get that, and then 15 is when all of the buttons are pressed at the same time. We get complete blank, and that's what's designed in the data sheet, and that's what's designed to appear. So that's the use of the BCD inputs, and you can see that it drives this 7-segment display very well, and it's a very useful circuit a very useful IC rather for driving such a display. Again, remember I said this is a common anode 7-segment display. If you want to drive a common cathode 7-segment display, well then you need to use a 7-4 LS48, and that drives a common cathode display. I actually plugged in a common cathode display in this to see what would happen, and what happens is you get the exact opposite of what you want. The segments, if you were to use a common cathode display with a 7447, you would get the segments, and it would be stuck with this wiring. I don't think there's any solution to it. The segments that you want to light are off. So in the case of 0, the middle section will be lit. If I wanted 1, everything except for the segments that are lit there will be lit, and so on. Finally, this display has a maximum rating of 2.5 volts at 20 milliamps on any one of the segments. You need to choose a suitable resistor value for this. It's probably 125 ohms. If we're using it for a short period, the 100 ohm resistor in our kit is fine to drive this display.